What is up out there? Today is day 27. I just wanted to do more implicit practice. We did a great job today working through those difficult multiple choice questions from AP exams. So I just want to do a little bit more practice with implicit. Right now we have the function, and not the function, actually it is a function, but we have the curve x squared y cubed equals 72. I want you to do these four things. I want you to find dy dx. I want you to evaluate dy dx at the point 3, 2. I want you to find the second derivative I want you to find the second derivative, and then I want you to evaluate the second derivative at the point 3, 2. I'm going to add into part B equation of tangent line, just to make it a little bit more interesting. So I also want the equation of tan line. Why don't you pause the video here and try to complete all four of these steps. Find the derivative, evaluate the derivative at 3, 2, so we can get the equation of the tangent line at that point. Find the second derivative, evaluate the second derivative at 3, 2. See if you can do all those steps on your own. So pause it here, go ahead and work on that, and then unpause it to see all the answers. Okay, we're back. Easiest thing to do here to find this derivative is we want to use implicit differentiation here. It's not the only way that you could solve this, but it'll be probably the simplest way. So we see here we have x squared times y cubed. So we should immediately recognize that this is going to be a product rule problem. So let's go ahead and do that. The derivative of the first is 2x times the second y cubed plus the first x squared times the derivative of the second, which is 3y squared dy dx. That is the complete product rule, derivative of the first times the second, plus the first times the derivative of the second, equals the derivative of 72, which is 0. Cleaning this up a little bit, I'm going to go ahead and call this 2xy cubed plus 3x squared y squared dy dx. It's not a step that you have to do, but it makes it a lot easier to have this neatly written so we don't lose track of terms. Now we want to solve for dy dx. So I'm going to subtract 2xy cubed to the other side. I've got 3x squared y squared dy dx equals negative 2xy cubed. And then I'm going to go ahead and divide by 3x squared y squared. And I got dy dx equals negative 2xy cubed over 3x squared y squared. Now this is all fine and dandy. This is the derivative. But since we're going to do a couple other things here, it's going to be helpful for us to simplify dy dx. Again, you don't have to make this move, but you're definitely going to want to. If this comes up on free response and you need to continue and do these other parts, we're going to want this thing as simplified as possible to make it easy to do without a calculator. So simplifying here, the negative 2 and the 3, that can't simplify. But we do have an x on top and bottom, and we have 2 y's on top and on bottom. So simplifying this thing, I get that x is going to be gone. This x is going to lose one of its. This whole y squared is going to be gone, and this is now going to be y to the first. So I end up with negative 2y over 3x. Okay, so I end up with negative 2y over 3x. That is my dy dx. I'm going to circle it here. And I'm done with part A. Moving on to part B, I want to evaluate dy dx at the point, 3, 2. And then I want to write an equation of a tangent line. So let's do that. evaluating this dy dx at the point 3, 2. I'm going to plug in a 3 everywhere I see an x. I'm going to plug in a 2 everywhere I see a y. So it's going to look like this. And I'm going to get negative 4 over 9. So we had a slope of negative 4/9. Writing the equation of the tangent line is very simple. We get y minus 2 equals negative 4/9, x minus 3. So we can check off part B. Now moving to part C, I want to find the second derivative. Okay, well I'm going to start with my first derivative, which I can see in part A is my answer. So I'm going to start from the first derivative, and it's going to look like this. So I'm starting there. I'll go ahead and circle this again. This isn't my answer, but I want to circle it so it's easy to plug back in. Now I'm just going to go ahead and do the derivative on both sides. The derivative of dy dx is that funky little notation we use for the second derivative. Again, what rule am I going to use here? Well, I have a function, negative 2y divided by another function, 3x. So I need to use the quotient rule. So I'm going to do the derivative of the top. Now the derivative of the top has y in it, so it's going to tack on a dy dx. So I have negative 2 dy dx. That's the derivative of the top times the bottom minus the top times the derivative of the bottom. All over the bottom function squared. So it's all over 3x quantity squared. So this is what I'm left with after setting up the quotient rule. I need to find, I think I forgot to put this in there, but it should be obvious. We need to find the second derivative in terms of x and y. We can't leave that dy dx in there. So let's go ahead and clean this thing up a little bit. Before I plug in for my dy dx, I want to simplify this thing as much as I can first, just to make life a lot easier for me. So I got negative 2 times 3x times dy dx. I'm going to call that negative 6x dy dx. Okay. Then I'm going to have plus 6y over 9x squared. So that's what I end up with. So breaking this thing down a little bit more, I noticed that 6, 6, and 9 are all divisible by 3. So I'm going to call this thing negative 2x dy dx plus 3y over, oops, not 3y, 2y. Over 3x squared. Okay, let's take a look at that, see if that looks right. Good. Now I can't simplify anymore, so now I'm going to plug in my dy dx. So I have it handy dandy circled right here. So I'm going to put in negative 2y over 3x for my dy dx right here. And my second derivative is going to be negative 2x times, now I'm going to sub in my negative 2y over 3x plus 2y, whole thing over 3x squared. Now again, this would be sufficient for an answer on free response. Since we're going to evaluate this thing, it might be easier to go ahead and simplify this thing down a little bit. Again, free response, I would circle my answer right now. But I want to practice my simplification so we can get better at it, because we're going to need to do it. Okay, I am multiplying negative 2x over 1 times this. I can get rid of my x's right off the bat. And I got negative 2 times negative 2y, which would be positive 4y over 3, plus 2y over 3x squared. Now I'm going to go through and get rid of that fraction within a fraction. So I'm going to multiply everything up top by 3, multiply the bottom by 3, and I get 4y plus 6y over 9x squared, which becomes 10y over 9x squared. So I get 10y over 9x squared is my final nicely simplified answer here. So that's the end of part C. Part D then, I need to evaluate my second derivative at the point 3,2 again. So that's going to be 10 times, subbing in for y, I'm putting in a 2, over 9 times 3 squared. 10 times 2 is 20. Over 3 squared is 9, 9 times 9 is 81. And I don't think that simplifies, so we can leave it as is. Done. As always, thanks for watching. And we'll practice this a little bit more tomorrow. See you then. Bye.